Hello again, my fellow pilots and my fellow aircraft maintenance personnel. Let's have some question on the Airbus A320 CFM engine ignition and starting. How does the starter operate? Pneumatically, electrically, or hydraulically? The starter is an air starter, so it will operate pneumatically. Okay. So, in this session, we will have some question on the Airbus A320 CFM engine ignition and starting system. Okay, let's continue. In which case can the ECU abort the start? Automatic start and manual start, automatic start only, wet motoring. The engine can abort the start in an automatic start. In case of manual start, only some critical fault like EGT, over limit, or stall, maybe the EEC can abort. But in many other cases, only on automatic engine start, the EEC can abort the starting sequence. Okay, everybody. Please don't forget to subscribe to my YouTube channel, Aviation Nuggets by Haitham Ali. Here you can find many other questions on the Airbus A320 family. Not only I give you question, but I give you the model answer and explain the question. Okay, let's continue for the next question. Of which type is the ignition system? The ignition system: low voltage, low energy, high voltage, high energy, low voltage, high energy. The type of the ignition system is high voltage, high energy ignition system. Okay. Next question. To increase aircraft dispatch, the start valve is equipped with manual override. This statement is very true. Yes, the start valve has a manual override in case of failure of opening the start valve automatically, or automatically by the EEC, or from the start panel, engine manual start panel. The ground mechanic can access the start valve and open on a signal from the pilot. When the air pressure is available, he can open the start valve manually. Okay, everybody. Let's proceed. Next question. During cranking, ignition is inhibited. Yes, crank is vice versa of ignition. Mode normal selector. It can be ignition start or crank. Crank mean no ignition. We do crank or we do dry crank in case of tailpipe fire. It's called dry crank or dry motoring in case of tailpipe fire. And the maintenance people do wet crank after maintenance on the engine to allow the fuel just going into the fuel circuit without ignition, to see if there is any leak and to see and to check on the maintenance task. Okay, so crank in meaning is no ignition. We have dry crank. Dry crank is no ignition and no fuel. Wet crank, no ignition but with fuel. Okay, everybody. Let's proceed. Next question. Continuous ignition can be selected via the ECU only manually from the rotary selector. This statement is false. Because continuous ignition may be selected from the rotary selector by the pilot, and also the ECU may elect to do continuous ignition in heavy weather condition or in selection of wing anti-ice or engine anti-ice. Also, the ECU has a privilege of choosing or selecting continuous ignition. Next question, everybody. I hope you enjoy this set of questions. During wet cranking, fuel is on when the master lever is set to on. Yes, if we do here like crank, open the start valve, and if we put the master lever on, fuel will be on. So this statement is true. This statement is true, everybody. Okay. Next question. Maximum EGT during start is 1025, 725, 550. Maximum EGT during start is 725 degrees centigrade. We have maximum EGT during engine start and the maximum EGT during toga. Okay. The ECU can abort the start sequence. ECU can abort the start sequence up to how much of N2 during automatic start? 40% N2, 55 or 50% N2. The ECU can abort the start sequence up to 50% N2. At 50% N2, the ECU cuts ignition and disengages the starter from the starting sequence. Okay. During engine start, at how much percent of N2 the ECU will close the start valve and cuts off the ignition? We just said it, 50% N2. 50% N2, the ECU will close the start valve and cuts off ignition. The ECU can close the starter valve and cuts off ignition at 50% of N2. With the master lever at off, the low pressure and the high pressure shut-off valve are closed. Yes, this statement is very true. High pressure fuel shut-off valve will close only with master lever off. High pressure fuel shut-off valve will close only with master lever off. Low pressure fuel shut-off valve will close with the master lever off or from the fire push button releasing. Fire push button releasing. Okay, everybody. Next question, the master lever is set to off. Engine start will abort as the master lever directly energizes the high pressure fuel shut-off valve solenoid. This statement is very true. Yes, the high pressure fuel shut-off valve on the engine is directly closed with the master lever. Releasing the fire push button in case of fire situation only close the low pressure fuel valve. Low pressure fuel valve may be closed by the master lever off or releasing the fire push button. But the high pressure fuel shut-off valve on the engine will only close with the master lever only. Master lever on. In manual start, both igniters are in. In manual start, both igniters are in. This statement is true. Yes, in manual start, both igniters are coming to have fuel air mixture burn at different location inside the combustion chamber. So we assure a high efficiency starting operation. This is the function of dual ignition. This is the function of dual ignition or dual igniters. Okay, everybody, let's proceed. Next question. In manual start at 50% of N2, what happened? ECU cuts off the ignition, start valve automatically closed by the ECU, all the mentioned above. At 50% N2, the start valve will close and ignition inhibited. Okay. Continuous relight automatic selection is provided by the FADIC when ignition delay sensed during start and in case of restart in flight, EIU failed and engine flame out detected, engine anti-icing selected. On all these cases, the ECU will elect to do continuous ignition. In all these cases, the ECU will elect to do continuous ignition or continuous relight. It is done automatically by the ECU. Also, if the pilot at any case, if the engine is running, having the mode selector to ignition start, That means he select continuous relight on the already starting engine. Okay, everybody. CFM56-5B starter duty cycle is 2 minutes on, 16 off, up to 5 times, and then 15 minutes off for cooling. This statement is false. This statement is false. Okay, everybody. Next question. Starter can be re-engaged when the N2 speed is less than 20%. Starter can be re-engaged when the N2 speed is less than 20%. Yes, this is the starter engagement speed. N2 must be less than 20% to engage the starter again. To engage the starter again. After any wet crank procedure, we need to assure that a dry crank is happening. Yes, to have all the fuel in the combustion chamber to go out of the aircraft. To go out of the aircraft. What provides the selection of the igniters A and B? The ECU, the ECAM control panel, the engine panel. Provides the selection of the igniters A and B, the ECU. The ECU. In automatic, it select one igniter. If we do manual start, both igniters are coming. Both igniters are coming. What happens in manual mode when N2 reach 50%? Start valve is automatically closed. Manual start push button on light goes off. The ECU provides to the ECAM message telling to close the start valve. Start valve is automatically closed when N2 reach 50%, even in manual start. Even in manual start. What causes an automatic continuous relight by the fatigue? Flame out detected, ECU failure, ignition start selection. By the fatigue, flame out detected, yes. In which case will the fatigue abort the start sequence either in automatic or manual mode of starting? High pressure fuel valve not open, ignition fault, or EGT over limit? EGT over limit. In this case, if we do attempt manual or automatic start, the ECU will abort the starting sequence. Will abort the starting sequence. Okay. How many ignition boxes are there on the CFM56-5B engines that power the A320 family? Ignition boxes are 2. They are 2. The ignition boxes transform 115 volt 400 Hz AC into high voltage 15 to 20 kilovolt. Yes, this statement is very true. It is the function of the ignition box. This is the function of the ignition box. The ignition leads are fan air cooled in the core engine area. Yes, the ignition leads are fan air cooled in the core engine area by the fan air. By the fan air. The left igniter is for system B and the right igniter is for system A. Left igniter for system B and right igniter is for system A. This statement is true. Yes, we do have dual ignition system for redundancy, for if any ignition system fails, other will take on, and also to ignite fuel air mixture in different location inside the combustion chamber. Inside the combustion chamber. A start valve is at the 3 o'clock position on the right side of the fan case. Start valve is at the 3 o'clock position on the right side of the fan case. This statement is true. This statement is true. Aft looking forward. Aft looking forward. No running engagement of the starter when N2 is above 20%. Yes, starter engagement speed is 20%. So the RPM of the rotor must be less than 20% to engage the starter. To engage the starter. The air starter position is at the 4 o'clock on the AGB rear face. Yes, this is the air starter on the rear face of the accessory gearbox. At the 4 o'clock position, we are rear of the engine looking forward. Thank you always for your good listening, and please stay tuned for an upcoming sessions like this. Also on my YouTube channel, you will have many questions like this. I explain the aircraft system of the Airbus A320. This question bank is made by Haytham Ali as a performance support to my fellow pilots and my fellow aircraft maintenance personnel. Thank you always for your good listening, and always fly safely and maintain your aircraft very safely. From Cairo, Egypt, your host was Haytham Ali, and I will meet you again very soon. Thank you and goodbye.